A sample of lead with a specific heat capacity of 0.128 joules per grams per degree Celsius absorbs 11.3 joules of heat, so we know Q. Rising in temperature from an initial temperature of 26.0 to a final temperature of 38.0 degrees Celsius, find the mass of the sample in grams. So we know that Q is equal to mc delta T. We know the quantity of heat, that is 11.3 joules. We know the specific heat capacity, that is 0.128 joules per grams per degree Celsius, and we can easily find the change in temperature because we know that delta T will be equal to the final temperature minus the initial temperature, which means if you plug in the values given in the question, that would be 38.0 degrees Celsius minus 26.0 degrees Celsius, which works out to 12.0 degrees Celsius. So we know delta T. We want to find the mass. We can rearrange this equation by isolating the mass m. If you divide both sides of the equation by C delta T, Q divided by C delta T will be equal to m. And then we can plug in all the values. Q is given as 11.3 joules divided by the specific heat capacity C is given as 0.128 joules per grams per degree Celsius, and the change in temperature we have calculated it as 12.0 degrees Celsius. Joules will cancel out joules. Degrees Celsius will cancel out degrees Celsius. So we are going to end up with a unit of grams, which is specifically what the question wants us to find. If you plug in all of these numbers into the calculator, you will get m equals to 7.35677.0833 grams. But we know we need to round it appropriately. All the measurements given to us are 3 significant figures. So this will be rounded to 7.36 grams.